Hey guys, welcome to another episode of Cuda Education. We are on a new series called pipelines.cpp. Before we get ahead of ourselves, just want to give a shout out to Sascha Willems for providing this freely available code on GitHub, pipelines.cpp, and yeah, helping the world to learn Vulkan one algorithm at a time. So, um, if you want to join in on the fun, if you want to be able to run these examples and get Vulkan on your system, assuming you have a Windows system with a Vulkan capable GPU, again, a Windows environment with a Vulkan capable GPU, you will be able to run, you'll be able to get to where I'm at with these examples installed on your system if you get tutorial number 1 and tutorial number 13. I'll have links to them down below. Tutorial number 1 is installing the Vulkan API on your machine. Tutorial number 13 is installing the Vulkan examples like this one that we have here. So it's two separate parts. You have to install Vulkan on your system, and then you have to install the examples. This particular pipelines situation, what it does is it's three pipelines that are basically being pushed to the screen. Now, these pipelines are slightly modified version of a base pipeline. So you have this one, and then you have this one with color, like a cartoony theme, and then you have this one that's like a wireframe. All right, so three separate pipelines. I'll get into the particulars of it, but basically, I will go through to a certain extent pipelines and stuff, which is a big thing in the Vulkan API overall, right? You have to understand pipelines and understand what it signifies and the nuances of it and everything. But let me not spend too much time. But just notice that this is the algorithm here. You have a wireframe, tune, and then a regular situation here. You could rotate the scenes just like with the gears as before. I'm saying we got some mushrooms here and all that, we got a little bit of money, a little bit of treasure, what have you. You can't complain with this scene, right? So beautiful scene. But yeah, so what I basically want to dive into is render area, viewport, and scissor. All right. So the render area now is where you're rendering to. Okay, so you have render passes and all of that stuff, right? So the render area, basically you're telling Vulkan, okay, this is the region of the screen that we're going to render to. So for example, I could say, okay, Vulkan, I'm only rendering to this area of the screen, right? Or this area of the whatever you want to call it. We're only rendering here and nowhere else, right? It is a good thing to have this explicit declaration because in certain environments, I believe Vulkan, can make certain optimizations based on based on the fact that you have this render area, and it's a distinct explicit area and nowhere else, right? So maybe Vulkan can do some optimizations, right? So that's your render area. All right, now you have your viewport. Now the layman's terms and how I thought of viewport is just basically the screen, right? So your viewport is, okay, this is the screen that you assume, or this is a screen that is relevant to your application or what have you. The driving force of what makes a viewport is that the viewport generally dictates the coordinate system. I mean, a sort of a semi-formal version of it says the viewport is a normal device coordinates transformed to pixel coordinates of the frame buffer. I don't really want to get into that word frame buffer right now, but basically it's a coordinate system. So whatever you define the viewport, it's going to affect how your coordinate system is laid out. Okay, so that's your viewport. It drives and affects the coordinate system. Okay, The render area doesn't drive and affect the coordinate system, but the viewport does. Okay. Now the scissor is sort of like, it's sort of like the window to your scene. So the scissor is a portion of the viewport that's actually visible to you, right? So the viewport might be the whole screen, but then the scissor is like only the top half. Okay, so if the scissor is only the top half, then you're only going to see the top half of the screen. Now that does not mean that the coordinate system or the layout of the scene is changed because you changed the scissor. All you've done is you've changed the window that you could look at the scene with, right? It's sort of like a viewfinder, right? Viewfinder, like what's a viewfinder and where is a viewfinder and what section is a viewfinder focused on? That's it. That's all the scissor is. It is the section that's actually viewable or you could see. All right. So that's the scissor. I'll get into the frame buffer after, but let's just focus on those three for the time being. All right. So let's remind ourselves how the scene looks. So this is the scene right here. And we could see that it is what it is, right? Remember we got our little mushrooms here, red mushroom. Okay, so that's the scene right there. All right, so now we're gonna change the height of the render area to that, right? So we're dividing by 2, right? That's all we're doing. Notice that it's the same scene, it's just that now where we're rendering to is just this piece right here. Nothing changed except where we're rendering to. Now we could still rotate and move around and do all that we want to do. No problem. No one is complaining. No one is fighting you. We could still do that. It's for all intents and purposes, it's just this that we could see. Okay? So that's render area, right? Where the section that we're rendering to. I don't know if there are performance implications because we're only rendering to that section and not the whole screen. I don't know. But that's render area. Now let's do the same thing in Scissor. Okay. Now if we look at Scissor, we're gonna see that it's the exact same situation. The whole scene might be rendered to, the whole screen might be rendered to, right? The entire screen might be rendered to, but our viewfinder, our window to the scene is only this. So we see only this. Now, if you look, we still are able to do everything that we did with modifying the render area, okay? We're still able to do everything that we did. It's just that the view of the scene is this piece. So the way I look at it is that in a lot of ways, your render area and your scissor could be synonymous with each other, right? Based on this instance and just kind of how I think about it. I could do if I could only render to a certain part of the screen, it's the same as saying I could only view a certain part of the screen. Notice that the dimensions between either one that I do, notice that the dimensions of the scene hasn't changed. This is now back to normal. But when I chop it off here, notice that the length of the bark of the tree is still the same. The length of these little grass things are still the same. Nothing has changed. The coordinate system is maintained. It's just the window, whether I say, okay, I want to just render to this piece or I want to just view this piece, in my eyes, it's sort of the same thing, right? I didn't really even know that render area was a thing until like I started investigating this this algorithm. I noticed that you define the render area in your VK render pass begin info construct, right? So it's defined here, but this is just typing on the CPU. But then it sort of gets digested and processed when we get to here, right? Because this is when this is a VK function, and then this is where everything that we're declaring actually gets processed, right? Notice that there's a command buffer and then begin render pass, right? So so the render area is a thing, all right? So we have our render area and we have our scissor, right? And they're kind of synonymous. We could kind of achieve the same things. As far as performance implications, I can't vouch for that. Maybe if you're rendering to the whole screen, but then only viewing a portion of the screen, the performance will be, lower than if you're just rendering to that piece of the screen, right? I don't know. Now let's change the viewport, all right? And let's see what happens with this, all right? Notice now with the viewport change that we're now distorting the coordinate system. The entirety of the scene is now compressed within this height right here, okay? So we're no longer just looking at the window of part of the scene. We're looking at the whole scene, but just in a smaller window, right? And this is the sort of the intellectual distinction that you have to make. You don't want to be careless with the viewport because you're literally changing the coordinate system of your whole scene. So that's a very important thing to understand. I could still do the same things that I do, but notice that everything now is distorted because the coordinate system has changed, right? And we're dealing with a smaller area, all right? So that is the viewport, okay? Truth be told, I tried messing around with the width side of stuff, but it just wasn't as clean, and I think I don't know, it was just, but anyway. So that's your viewport. If I do a third of what was before, we're gonna get even smaller. Okay? If I do a fifth, we're gonna get even smaller. Okay? And if we take it out completely, we're back to what we had before. All right? So creatives, talking to you. You guys could play around with it and all that stuff. Okay? But that's your viewport for you. With the render area, I think we could also mess around with the offset and stuff. Right, so it didn't run. We do 100. We do minus 40. I think that's what it was. So, right, it was a minus value. Notice that there's a little bit of an offset here. Okay? So you guys could have at it. All right? Right. So, you guys could figure out what have you, but you see render area, that's that. So okay, I promised that I would talk about Framebuffer, but I need some more experience with it to really, I mean, part of the formal definition or semi-formal, I don't even know, casual definition of what frame buffer. The frame buffer is point beyond which no rendering can happen. If a generated fragment falls outside the frame buffer, it is discarded. Fragments, right? So there's a thing called tile architecture, like the way how the GPU works is tiling. So every a scene is a bunch of tiles that are put together, right? And it's like you put a puzzle together to make a scene, right? If the GPU creates a particular tile, but then the tile, like if you create this tile here, but the tile falls outside of the frame buffer, then that whole tile is discarded. So you might see like this whole piece just be empty or cut out or whatever, right? So that's one sort of way to attack this frame buffer idea. And notice that the frame buffer is referenced here. It seems to be a very important thing, but I didn't really even notice. I mean, I knew about it, but I didn't necessarily know about it in terms of this render pass situation. I knew that it's important. In one of my videos, which I will link down below, it's called the Scissors Viewport render pass video. And one of the videos, I where I have the swap chain and the boxes down below. You sort of have at the first big box, like the outer box is the render pass, right? So the render pass, you have your render pass, and then within the render pass, the next level of the hierarchy is the frame buffer, right? Within the frame buffer, you have a next level called the image view, then the attachment, and then the image. This hierarchy is basically, in my opinion, the reason for it is to give the programmer as much options as they want and control over everything. What do I mean by that? In order for a render pass to interface with an image, it needs to go through the frame buffer. It has to go through the frame buffer, then the image view, then the attachment, and then the image. So basically, if the render pass wants to jump to an image, it has to go through these gates, if you will, or these concepts, right? So a render pass can't have access to an image without going through the frame buffer. And the frame buffer can't have access to the image without going through the image view. And then you have a next layer called attachment, and then you have the image itself. All right? So another sort of definition of frame buffer, a wrapper that has to be used with a render pass to access images. Right, check out swap chain render pass video below to see the diagram. It manages attachments, etc. So that's pretty much what a frame. It's another layer of organization that you kind of need to be wary of. There's talk of, the frame buffer, it can't, if the frame buffer is smaller than the viewport or something, it will crash or it won't work, all of that stuff. But it's something that we have to be mindful of, and you see that it's referenced here, but I can't, I don't have enough information about it to talk about it. Yeah, all right. Let me jump. I'll jump to the next video to talk about a different topic. But just understand, you have, with your render pass, you have your render area, then you have your Scissor, which is basically your viewfinder. What window are you going to use to look at your scene? And then you have the actual viewport, which is basically the dictating the coordinate system of the scene, right? And that's that. Notice that first you have the command buffer, and then you have the render pass. And the viewport and the Scissor is sort of within the render pass, right? Because CK, VK, CMD, begin render pass is called first, and then we define the viewport and the Scissor, which I'm sure it's important to know. So you have your render pass, and then the render pass, implicit in the call, you dictate your render area. So the render area kind of is sort of defined first, because you you implicitly call it within this render pass call, and then you define your viewport, and then you define the scissor. A lot of times the scissor and the viewport is the same, right? So what that means is that your viewfinder is the viewport. Your viewfinder is the whole scene, right? So you're looking at the whole scene based on the viewport. But you know, when people want to be creative, which is why I keep shouting out you guys, you creatives out there, when you guys want to be creative and create something cool or create something interesting or create something really nice, you could play around with these constructs to make something cool. By the way, guys, one of the greatest and best video games out there that's ever been created is the PlayStation generation of Metal Gear Solid. You know, truly amazing video game. Just felt like throwing that out there. Like and subscribe to the channel. Get your friends to plow through this stuff. It's better to work in a group. It's better to learn in a group. Yes, you could play your video games, but you know, put a little coins into actually learning how video games are made, and maybe one day you could make your own video game. Like and subscribe, share the video. Check out tutorial number 1 and tutorial number 13 to get the get this running on your system. All right, thanks for watching. Have a great day.